In this video, I'm going to talk about exponential growth functions. Specifically, we're going to deal with exponential growth functions. This is from chapter 7, section point 1. So first, let's define what an exponential function actually is and what it looks like. An exponential function is any function that takes on the form y equals a multiplied by b to the exponent x, where a cannot be 0, is not equal to 0, and b cannot be 1. So yesterday we talked briefly as to why a cannot be 0 and b cannot be 1, so I'm going to refresh your memory. A cannot be 0 because if you plug in a 0 into this function, so we have 0 times b to the x, it doesn't matter what happens with b to the x, you're always going to have any b to the x value multiplied by 0. And as you know, if you multiply any number by 0, the whole thing becomes 0. So if you plug in 0 into this a, you're always going to get the value come out 0, which doesn't fit with our description of what an exponential function needs to be. Now, if b is 1, if you plug in a b here, it doesn't matter what exponent you raise it to, 1 to any exponent is still going to be 1. So if that x that you plug into this exponent is 5, so 1 to the 5, that's still 1. 1 to the 20th is still 1. 1 to the 5 millionth, it's still 1. So what you're going to have is a multiplied by 1. A multiplied by 1 is just going to give you a. So in that case, we're just going to be left with a straight line at a, and that also wouldn't fit with an exponential function and what it's supposed to do. So an exponential function is this y equals a times b to the x. But a growth function is where b is greater than 1. Any number greater than 1 plugged into this b is going to make the function grow, and we're going to investigate that in just a second. But in order for you to have an exponential growth function, it has to be in this y equals a multiplied by b to the x, and b has to be greater than 1. A growth factor in that exponential growth function, y equals a b to the x, the growth factor is b. It's called the growth factor because that's what determines, or that determines by how much the function is going to grow. So whenever you're looking at these exponential growth functions and you're asked to identify or to point out what the growth factor actually is, just look at the b, just look at the number being raised to the exponent, and that'll tell you what the growth factor is. And from there you should be able to interpret by how much the function is growing every year. An asymptote is a line where the graph gets really close. So graph, this is going to take me a while to write because I'm using a mouse on a laptop, or I can use my brain. So it's a line that graph gets really, really close to, but never touches. So in an asymptote, excuse me, I had to correct my commas, my grammar. An asymptote is a line that the graph gets really, really close to. The graph always approaches, but it never touches. Okay, so now let's talk about the parent function for the exponential growth functions. This is what the parent function actually looks like. If you are able to graph this parent function, from there you can graph all other functions that you're given just by doing some stretches and some vertical and horizontal shifts that we'll discuss probably in a different video. So the function y equals b to the x, where b is not 1, is the parent function for the family of exponential growth functions with a base of b. So b is the base. The general shape of the graph of y equals b to the x is shown below. So we talked about this yesterday. See how the graph, this curve, is approaching the x-axis? It's never going to touch the x-axis. The x-axis in this case becomes our asymptote, and it's specified here. The x-axis is an asymptote of the graph. An asymptote is a line that a graph approaches more and more closely. What they left out is to say that it never touches. The graph rises from left to right, passing through the points 0 and 1 and 1 and b. Those points are pretty important to remember. So remember that the parent function passes through points 0, 1, 1, and b. I'll explain that in just a second as to why it always passes through those. The domain of y equals b to the x, we have to find that, and we also have to say what the range is. Before we can actually say what the domain and the range of this specific function is, we have to remember what the domain and the range mean. So the domain is all the x values where the graph is real, where the graph gives you a real value. What x values can you plug into this function and pop out a correct y value? Now, if you see, this graph goes on infinitely, forever. Well, you can't really see it, but if you can use your imagination. Goes on forever to the negative side, keeps rising, but it goes on forever in the x-axis. So the domain in this case goes from negative infinity all the way to positive infinity. The x values go all the way back to negative infinity, all the way up to positive infinity. And the range of any function is all the y values that this function takes on. So you can see here, you have the arrow pointing, it just keeps going up and up and up and up. It never ends. So the ending of the domain, it does go all the way to infinity. But does it keep going all the way down to negative infinity? No, it does not. It gets really close to that x-axis, but it never touches or never goes over it. So the smallest value that you can have in this function for y is 0. So the domain starts at 0, goes all the way to positive infinity. Okay, so now that we know how to graph the parent function, let's look at what happens when we have something happening to the parent function, some sort of change or alteration to the exponential growth function. So we have y is equal to a times b to the x. What changed here is that now we have an a in front of it. Now if you remember from yesterday, we said that the a gives a vertical stretch or compression or shrink. Stretch or shrink. This takes forever. Okay, so now what we need to notice about the function with the a in front of it is that it's going to pass through 0 and a. It also passes through 1 and a times b, and the asymptote is at the x-axis. If you remember from the parent function, it always passes through 0, 1, and 1b. Here we're going to change it up a little bit. It's not going to pass through 0, 1, and 1b. It's going to pass through 0 and a and 1 ab. So it has the asymptote at the x-axis. So if you're asked to graph this, graph the function y equals 1/4 times 6 to the x. Remember, we need to plot our two main points. It's going to pass at 0 and a. Our a in this case is 1/4. So this is going to pass through 0 and 1/4. And it also passes at 1 a times b. So we're going to have to multiply 1/4 times 6, we get 6 over 4. And that can be simplified to 3 over 2. That's a 3. Then from left to right, draw a curve that begins just above the x-axis. It doesn't begin at the x-axis because the x-axis is an asymptote, never touches it. Passes through the points and moves up. So 0, 1/4, we can say it's here. 1, 3 over 2. 3 over 2 is 1.5. It's here. So get really close to the x-axis. And we're going to start moving up. Connect these lines. And we're done. It's a rough sketch. Doesn't need to be completely exact or to scale. Okay, let's go into one more example of how to graph these. Let's say that you're asked to graph y equals 2 times 3 to the x. You need to know what 2 points this graph would pass through. You know it would pass through 0 and a. In this case, our a is 2. And it would also pass through 1, a times b. In this case, our a is 2, our b is 3. Passes through 2 times 3 is 6. Still has the same x-axis as the asymptote. So this guy would do something like 0. We can say this is 2 here. 1, up 6. Get really close to that axis. And go up. But you will say, Mr. Cisneros, how do I know it's always 0 and 2, 0 and a, or 1 and b? Well, that is a very good question. Let's go back into this screen and try to prove that. If we have the function always passing through 0 and a, this 0 is the x value. So if we plug 0 into this x, we would have a multiplied by b to the x, and in this case our x is 0. Class, what is b to the 0 power? Just 1. Anything to the 0 power is 1. So you're left with a times 1, which is just a. Anytime you plug in 0 into this x-axis, into this x value, you're always going to be left with a. Now what if you plug in a 1? When you plug in the 1 to that x, you're going to be left with a multiplied by b to the first power. B to the first power is just b. Any number to the first power is just that same number. So you're left with a multiplied by b, which is a b. So our 0 value, our first point that it passes through is 0 for our x, a for our y. Second point that we know it passes through is 1 for our x, a, b for our y. Next video that I'll post, I'm going to go over the real world applications of these sorts of functions.